Alright, so the last problem on Unit 3, Worksheet 4 that I'm going to go over is the Michael Jordan problem. That's question number 4. And I'm going to start this with two graphs just to help illustrate some of these the problems here. So the first one's going to be his position, and that's meters and seconds on my axes. And so when an object is thrown in the air or jumps in the air, things like that, we know that the shape that graph is going to produce is, oh man, that's ugly, is a parabola. It's parabolic motion. And in this case, we know that the highest point here is 1.29 meters. We don't know how long it takes. That's one of the questions that were asked. The second graph that I'm going to draw is that of a velocity versus time graph. So we have velocity in meters per second and time in seconds. And for this graph, much like the ball toss lab, we know that Jordan's going to start off moving in the positive direction and end up moving in the negative direction. And at some point he crosses 0, and at the point he crosses 0, that's the highest point in his motion. So this point right here is max height. And again, that's important because that shows us that at his maximum height, his velocity is 0. So the first part of this question asks for takeoff speed, and that's going to go back to the same thing we did in question 3 with the kangaroo. Takeoff speed is asking for V initial. I do know that to his max height, he has a displacement of 1.29 meters. I do know that at his max height, he has a final velocity of 0 meters per second, and I do know that while getting to his max height, he has an acceleration of -10 meters per second squared. So now I have everything that I need to solve this problem. V final squared equals V initial squared plus 2a delta x. Plugging things in, I get 0 squared equals V initial squared plus 2 times -10 meters per second squared times 1.29 meters. Simplifying, I get V initial squared equals, let's see, that'll be 25.8 meters squared per second squared. And then lastly, V initial is the square root of that, which is plus or minus, but in this case only the positive answer is reasonable because he's jumping up. And so the square root of that would be 5.08 meters per second. And that's my final answer. Now, the second part of this is going to ask us about time. So I'm going to clear my whiteboard off here, but the knowns and unknowns stay the same. And now solving for time, what is his hang time? Well, now that I know what his initial velocity is, there are several ways that I can solve for time. One of which is to do it the simple way, and that's to look at the time to the highest point, because that's a simple one to do. I can use V final equals V initial plus AT. Now I know V final at the highest point, I know V initial, I know A, and I can solve for T to the highest point. So let's do that. 0 meters per second equals 5.08 meters per second plus acceleration negative 10 meters per second squared times time. And so solving for time here, I get time as 0.508 seconds. Now, that's the time it takes to get to the highest point. But the question's not asking the time to the highest point. It's the time to move up and down. Well, the total time is just going to be twice the time to the highest point because it takes the same amount of time to go up as it does to go down. So all you have to do then is multiply that answer by 2 to get your final answer of 1.02-ish seconds. That's rounded. And that would be the time to the highest point. The alternative to this method that you could also use is delta x equals 1/2 at squared plus v initial t. Now that I know v initial, and solve for time this way using this equation. I don't recommend it because in this equation time is in the quadratic, and that means you'd have to use the quadratic formula to solve for it, which is not pleasant. So this is possible, but discouraged. Not fun. Sad panda.